Hello and welcome back. Today the math puzzle is about helping Bart Simpson. He is working on a geometry problem and he needs to know if the area of each face of the cube is the cube root of 4, what is the volume? So we need to use some knowledge about the radical expressions because we have a cube root of 4 and a little bit of geometry. But we have the formulas here. The volume is a cubed, and you know the area of a face is a times a squared. Alright, we will get back to this puzzle later at the end of the section, because today we're going to work on chapter 7, rational exponents, radicals and complex numbers, and section 7.4, adding and subtracting, multiplying radical expressions. The first objective is to add or subtract rational expressions. The rules in the previous section allowed us to split radicals that had a radicand which was a product or a quotient. And if you remember, if you have a quotient, if you have a product, you can split. You can make two different radicals multiplied, and this was the product rule and the quotient rule. Yes? But we cannot do the same thing with addition. No. And just to illustrate, but keep in mind, this is something you cannot do, it's not allowed. So let's say we have, the square root of a plus b. You cannot split this. You cannot, let's say, it's different from square root of a plus square root of b. Right? You cannot say this is an equality, because it's not. There's no property. There's no such a property. And the same thing if you subtract a minus b, never equals to square root of a minus square root of b. No. Okay? And we will be able to add by identifying like radicals, which are the radicals that have the same index and the same radicand. Like radicals that can also be combined with addition and subtraction using the distributive property. Let's understand with the examples. We're working on a few examples, and check this out. We need to identify like radicals, and we have square root of 3, the same index is the square, and the same radicand is the 3, and we have another one here. They are like radicals. The coefficient is 1, so we can add the coefficients. 1 plus 7, 8. The square root of 3. This is how we add, how we can simplify and add radicals, okay? By combining like radicals. Kind of the same thing you do when combining like terms. Another example, 10 times square root of 2 minus 4 times square root of 2. So the square root of 2, they are, and the square root of 2, they are like radicals, and we can combine 10 minus 4, 6, square root of 2, right? And another example, check this out. How can we combine square root of 5 plus square root of 3? Can you think about like radicals here? Well, first, they are 5 and 3. You cannot factor out. They are prime numbers. You cannot simplify. You cannot change. That means there's no nothing you can do. Nothing to do here. There's no simplification possible. Let's find out now an example letter B, if we can do anything. And we have, check this out, they have different radicands, right? They have the same index. The index is 2, because we're talking here about square roots. So the index here is 2, but the radicands are different. There's nothing you can do, we cannot combine. Now, what about this? We have square root of 2 plus 4 times cube root of 2. The radicands now are the same, 2, but the indexes are different. We have 2 in the square root, and you have 3 in the cube root. Again, nothing to do here, cannot combine, nothing to do. Right? We cannot combine. We don't have like radicals. Check another example. Simplifying the radical expression. And we have a square root of 27 plus a square root of 75. Well, they are radicals with the same index. They are square roots, the index is 2, but they have different radicands, right? One radicand is 27, another radicand is 75, but maybe if we factor them out, we can find something. Check this, because 27 is, let me write down, 3 cubes, correct? And 75 is 3 times 25, right? We can simplify, because 3 cubed is 3 times 9, and we can use the product rule, remember? Square root of 9 times square root of 3 plus square root of 25 times square root of 3. And now we will have square root of 9 is 3, square root of 25 is 5, now we can see, we can identify like radicals. Check this, we have square root of 3 and square root of 3. Add the coefficients, 5 plus 3, 8, square root of 3, and this is the answer, the result of the simplification. It was possible because you factored out the numbers and managed to find a like radical to combine. Now, moving to another example, try to simplify this radical expression. We have 3 times square root of 20 minus 7 times square root of 45. Again, we can break it into 3 times 20 is what? Square root of 4 times the square root of 5, right? This is 20. Minus 7 and 45, we have seen before, is square root, 45 I mean, is square root of 9 times the square root of 5. Correct? We can simplify. We can find the square root of 4 is 2. We can find the square root of 9 is 3. And as a result, we're going to have 3 times 2, 6. Square root of 5. Minus 7 times 3, 21. Square root of 5. Like radicals, oops, the square root of 5 is going to be a like radical, we have in both terms. That means we can combine the coefficient 6 minus 21, negative 15, square root of 5. That is the answer. Now let's try another example. Simplify this radical expression that we can see here. Negative square root of 75 plus square root of 12 minus 3 square root of 3. And let me use this green color. And we can write 75. We've seen before, right? Negative square root of 25 times square root of 3. This is 75. Plus 12. This is the square root of 4 times the square root of 3. Correct? And you just repeat minus 3 square root of 3. Cool. Check if you can simplify. You can find some square roots here. This is 5. This is 2. So we can we can identify like radicals. Square root of 3 we can find here, on this term, on the other term, is going to be a like term, right? Like term. We can combine the coefficients, so we have negative 5 plus 2, negative 3, minus 3, negative 6 square root of 3. Right? Now moving to the next example. Simplify the following radical expression. Assume the variables represent positive real numbers. Now we're going to have variables in the expression, and you may think it's going to be a little bit more complicated because now we have letters, we have variables. Just calm down. Let's work step by step. It's not going to be complicated. 3, and we can write 45. Just let's split. Let's use the product rule and break down this into different radicals, right? 45 is the square root of 9 times the square root of 5, right? 45, and the square root times the square root of x cubed, okay? Plus x square root of, and let's break it down. Make this 5x. That's okay. Check the square roots that we can simplify, that we can find the answer is 3, square root of 9 is 3, and we can have this is going to be, we can simplify, it's going to be x square root of x, right? X square root of x. So 3 times 3, 9, and we have square root of 5 times this. You agree with me? X cubed is the same thing as x times x squared, so we can remove one of the one x outside of the root. So this x square root of x plus x square root of 5x. We can bring together these two, because I think we will have a like term. I think we're going to find a like term here. Check this out. 9x square root 5 times x plus x square root of 5 times x. Nice, because now we have a nice like term here. square root of 5x and square root of 5x, we can combine. Combine the coefficients, 9x plus x equals 10x square root of 5x. That is the answer. That is going to be the answer after all the simplifications that are possible. Now, another question, another example. Simplify this radical expression. Now we're going to have cube roots, right? Cube root of 64 plus cube root of 14 minus 9. Well, think about what can we split? What can we do with those numbers? Because 64 is 4 cubed, right? 4 cubed is 64 plus, and 14, well, it's just 14, we cannot find, it's 2 times 7, 14 is 2 times 7, there's no, there's nothing we can do to simplify, there's no perfect cubed to simplify, so we just keep as cube root of 14 minus 9. As I can see, the only thing possible to simplify is this. We can find the answer for cube root of 64, which is 4. And then 4 minus 9 is, we keep this cube root of 14 that we cannot simplify. 4 minus 9, and that's it. That's all the simplification we can do. This is the answer. Now let's move to the next example. Subtract. Assume that all variables represent positive real numbers. And we don't have variables anyways. We just have numbers. I don't know why the question is talking about variables. The square root of 45 over 4, and we can write the square root of 45, remember 9, square root of 9 times square root of 5 over 4, minus square root of 5 over 3. And the square root of 9 is something that we know is 3. That means we can write the expression as 3 over 4 square root of 5 minus, this is going to be 1 over 3 square root of 5, right? I'm just doing this to show that square root of 5 is a like radical that we can combine the like radicals by combining, adding or subtracting the coefficients. So 3 over 4 minus 1 over 3 square root of 5. 3 over 4 minus 1 over 3, and we can make this like 12, 3 times 3, 9, 4 times 1 times negative 1 minus 4 square root of 5 over 12, right? That's right, square root of 5. Check if I did all the calculations right. I think so, because the answer is going to be 5 over 12 square root of 5. Now, the next objective, number 2, multiply radical expressions. Check the examples. We have to apply on this first example letter A, distributive property, right? So we have square root of 3, apply distributive property, and multiply by square root of 3 minus square root of 2 equals square root of, let me do step by step so we can see what is we are doing. Square root of 3 times square root of 3 minus square root of 3 times square root of 2. Apply the product rule. Remember the product rule from last section? Square root of 3 squared minus square root of 6, and 3 squared, square root of 3 squared is 3 square root, 3 minus square root of 6. That is the answer. Right? For letter B, this, I don't know if you still remember the chapter, section 5.7, special products. We have something like that. Let me write down here at the bottom so maybe you will remember. A squared minus B squared equals A plus B times A minus B. And we have something similar here, right? This could be A minus B, this A plus B, and this would be equal to A squared minus B squared. This is a special case product that's called the difference of perfect squares. So we can write this is equals to A squared, square root of 3 squared, minus B 8 squared. Right? Let me click this. This is the formula. You need to have a formula sheet or a notebook with all the formulas that you learn. Really easy to access, and because you don't need to memorize the formulas. You just need to remember, hey, I think this is something I've done before, and then you check on your notebook or a formula sheet and you're gonna find the formulas that you need. And square root of 3 squared is equals to 3 minus 8 squared is 64, and the answer is going to be negative 61. That is the answer. Let me use this. Nice. Cool. And I think this is the last example of this section. And let's use this orange color, nice orange color, because now we have another special case. Let me write here at the bottom, maybe you're going to remember. Is A plus B squared. This is another special case, is equals to A squared plus 2AB plus B squared. So we can use it, we can apply. Let me check. This is going to be A, number 2 is B, so we have A squared is square root of x plus 1 squared plus 2 times A square root of x plus 1 times B times 2 plus what? B squared 4. Okay? We can simplify this with this. So x plus 1 plus 2 times 2, 4, square root of x plus 1 plus 4. And finally, just erase this. This is just a formula that we used. This is equals, and we can have x plus 4 square root of x plus 1 plus, combine 1 with 4, 5. That is our answer. Yeah, you can change the order, but this is the answer. This is the result after all the possible simplifications, right? Okay, that is the end of section 7.4. And check if you know how to solve this. The area of each face of the cube is cube root of 4. What is the volume? On this math puzzle, we need to help Bart Simpson. So the area is equals to a squared, right? And a squared equals to cube root of 4. Nice. We need to find the volume. The volume is a cubed. Maybe we can just find a first, and a is going to be equals to the square root, cube root of 4. If you think about it, because 4 is 2 squared, this is cube root of 2, right? Cube root of 2. Then a cubed, you have cube root of 2 cubed. That means a cubed equals, simplify, 2. The volume is equals to 2. Volume, the volume of this cube, after you work out all the simplifications, you're gonna find this is equals to 2 cubic units. That is the volume of the cube. 2 units, 2 cubic units. All right, this is the solution of our math puzzle. Thank you for joining and watching the video.